Hi, this is Mrs. Allen, and in this video we will be talking about the t-distribution. The t-distribution is very similar to the z-scores. So first we're going to review that, and then you can compare the two to see how they're very similar. It might help you remember t-distribution. So if we look at the normal bell-shaped curve, 95% of the data lies in the center. Right here. Okay, so then on the tails, the two tails, the red area is the rejection area where 5% of the data lies, 2.5% on each side. This area is sometimes referred to as alpha or as the p-value, which just stands for the probability value. Okay, so let's look at the z-scores. The z-scores are located 2 standard deviations away from the mean. So the 1.96 down here, that's a z-score, and the negative 1.96 on the other side. So we say that if the z is less than or equal to negative 1.96 or greater than or equal to 1.96, then we can reject the null hypothesis. So let's look at the two shaped curves, the t-distribution and the normal, and see how they're different. So the normal distribution is up here, okay, and the t-distribution is down here. It's like squished down. It's less peaked in the center and has higher tails compared to the normal distribution. So let's look at the t-distribution. Here, the green area is where 95% of the area lies. Most of the scores will be there. The rejection area, again, the red area is 2.5% on each tail. And let's think about if we had a sample size of 2. Very, very small sample size. So then our critical areas, the t-scores would be 12.7 and negative 12.7 over here. So we would say if t is less than or equal to negative 12.7, or if t is greater than 12.7 or equal to, then we could reject the null hypothesis. Okay, so let's look at if we have our t-distribution and the sample size keeps increasing, then our curve is going to get closer and closer until it gets very close to the normal distribution. So larger sample sizes will make the curve go up to match the normal distribution. So the t-distribution will equal the normal distribution at very large sample sizes. So let's look at this chart. So the degrees of freedom are the sample size minus 1. So we only had a sample size of 2. 2 minus 1 would give us 1 degree of freedom. So if we look at 1 degree of freedom and go over to a two-tailed test where we have 5% right there, we get the 12.7 like I used in the graph earlier. Okay, if our sample size increases, let's say the larger we get, we're going to get 1.96, just like we do in the normal bell-shaped curve. So the larger our sample size, the closer and closer we'll get until we are just like the normal distribution. I hope this video helped you better understand t-distribution. Thanks for watching.